Hi everyone, this is Professor Lubimtseva with Lecture 6, Integrating Landscape Ecology in Sustainable Planning in GPY for 10 Landscape Analysis and Green Infrastructure. Today, my lecture is based primarily on the readings by Ahern. We are going to work with Chapter 10 by Ahern. This chapter is available on the Blackboard, and I would also use a couple of optional readings, so I recommend to use Leitao and Ahern optional article, at least skim it through, and it would be great if you could read it. If you have no time, at least take a look at the tables and a couple of pages that I am going to mention today that illustrate some examples of the concepts that I'm going to explain. So I'm going to set a framework for the conversation for today. What is sustainable planning? Why is it necessary? Why the landscape is suitable for planning purposes? What spatial concepts of landscape ecology are useful in planning? And how understanding landscape ecology can help in urban and land use planning. So we would really examine these questions today through a number of examples, and I encourage you all to think about them as you are working on your own project proposal. In this chapter and some of his other articles that we are going to examine later, Jack Ahern is introducing the so-called ABC approach, which is very convenient in planning as it brings together abiotic, biotic, and cultural elements of the landscape. Considering the landscape as a nexus between nature and culture, between geomorphological kind of heterogeneity of the landscape, biotic heterogeneity, and cultural heterogeneity. This is also the place where greenway planning, landscape ecological planning, ecosystem management, conservation planning, urban planning can come together. This idea is already quite familiar for you from the first reading that we had in this class when I spoke about the chapter and the article by Dr. Wu. So why landscape ecology is important in planning? Landscape ecology, as you know already, is the study which is concerned with interactions between the temporal and spatial aspects of various components of the landscape. And these components, as Ahern is explaining in chapter 10, include abiotic components such as landforms and water and nutrients and energy flow, biotic components such as flora and fauna, and cultural components such as any man-made elements within the landscape, urban infrastructure, recreational facilities, and so on. Landscape ecology addresses these ecological processes affected by the spatial structure of a large area, intervened by human activities, or this could be a natural system as well. Landscape planning attempts to influence specific changes in the pattern of landscapes with particular consequences for ecosystem structure and function. And so here, emphasis on this balance between abiotic, biotic, and cultural components is really coming handy because the goal of sustainable planning is to organize, function, and stay in such a way that we can find a good balance in those relationships between all three sides of this triangle, and the current planning activities can converge towards the core of the triangle, the center of the triangle, integrating abiotic, biotic, and cultural priorities. So you are already, this concept is not new. You probably remember the article by Professor Wu on sustainability science and landscape ecology, where he is speaking about this triangle, emphasizing the relationship between landforms and biota and human activity in the landscape as a system. I want to come back for a moment to my previous lecture, where I spoke about the relationships between process and pattern, or between function and form in the landscape. So I want to remind again, here are so many examples that we can deduce information about processes in the landscape from the pattern that we observe. And it's important to understand as we are developing our planning projects that any action that results in a change of a landscape form would also produce a change in the landscape processes. So let's say we drain the wetland, well, the entire ecology of this area is going to change. Or we build a new mall, again, the entire ecology of this area is going to change. So this is something that we need to remember, that as we are changing appearance, we are also changing all the processes, and alteration of any landscape component would also result in the alteration of all other components and imbalance of the system. So again, I want to reiterate the idea from the previous lecture. Landscape is a thermodynamic system, and as we change any of these components, it goes away from its equilibrium, from homeostasis, and it can be a very resilient system if it's fairly natural, if it's complex, if it's heterogeneous, but we have to remember that any changes, any disturbances are going to cause imbalance, and so in order to restore the balance in the system, we need to bring some other actions would be required, and some other energy and material are likely to be necessary to establish the new balance. So here are some examples showing where planners and landscape ecologists really need to work together, or ideally all our urban planners and land use planners really need to be also trained in landscape ecology to be able to consider those questions. For example, how large should a park be to function as a viable habitat for a forest interior species? Or what are the influences of humans on biodiversity value of a community park? Or how much of a buffer is needed adjacent to an urban river corridor in order to protect water quality and habitat values of this stream corridor? Or what processes are likely to be influenced by the planning project? Or what is the role of disturbances in the project development site? Now, I know that you are finishing right now your first round of project proposals, so this might be helpful, or you could also consider revising your proposals as you would be preparing the new version for October 30. Right now, don't worry about including everything from this lecture or the lab 4 into the project proposal, but I recommend that you look at the table 2 on page 72 in the optional article by Leitao and Ahern, and examine how the landscape pattern is related to the landscape processes. So you will be doing a very similar exercise in the lab 4 that I was explaining today in the tutorial. So think about what would the changes of the landscape pattern cause the changes in the process, how it's actually working in your study area, and why. A couple of important concepts to introduce from chapter 10 is the relationship of chorology and topology in the landscape. So we spoke before about many chorological relationships within the landscape. And of course, you probably have heard before about topological relationships, especially if you are taking GIS classes. It's important not to confuse topological and chorological relationships, even though both refer to spatial connections within a certain place, within a certain landscape. So topological relationships are vertical relationships. We refer to topological relationships as we are thinking about what is happening among different layers. Like, think of the landscape as a cake with many layers, and these layers could be landforms and soils and vegetation and animals and humans and microclimates. So all those layers are interacting with each other, and you think of those vertical connections. For example, landforms influencing type of soils, and vegetation is also influencing type of soils, but soils are influencing type of vegetation that you have. And this vegetation and soils are then determining microclimate, and they also affect hydrology. So again, hydrology is affecting microclimate. It's also affecting vegetation, as vice versa. You see here many processes and many positive feedbacks being, or negative feedbacks as well, being engaged. All this is happening vertically. I spoke today about it also in the lab 4, if you watched the tutorial from Hager Park. On the other hand, so in the topological relationship, we study connections between various strata, right, such as soils, water, vegetation, climate, animals, human actions. These are called together with a very short-range energy and information flow in the horizontal plane, the topological relationship. So classical detailed ecosystem study has been typically restricted to the topological dimension, and some of you probably heard about topological dimensions in GIS classes or in some other geography classes. On the other hand, chorological relationship, there is also another type of spatial relationships, really refer to horizontal processes and horizontal connections within the landscape. As we approach the landscape from chorological perspective, we are really looking at the landscape from we imagine the bird view of the landscape. So in labs 1, 2, and 3, you mainly were focusing on chorological or horizontal relationships within the landscape, exploring how patches and corridors and matrix are related, and you were making those sketches. You were really looking at the landscape as it appears on the map. Now, I want to remind we should not confuse chorological, that refers to place, with chronological, that refers to time. We're not talking right now about time. We are comparing topological and chorological, so they both are related to place, right? Topology and chorology. So chorological dimensions. In chorological dimensions, units of the space are studied in this dimension, maybe complexes in the shape of a landscape mosaic, consisting basically of various topological units, and these units can be patches, these units can be corridors, it can be different parts of your matrix. So the relationship studies concentrate especially on the horizontal processes between the patches and the Earth's surface. Those are the so-called chorological relationships. So our lab 3, for example, was entirely focusing on chorological relationships in your study area. In this chapter, and we would also do it in the lab 4, Ahern is talking about the usefulness of landscape ecology metrics. And again, I encourage you, in addition to the required chapter, also read the article by Lei Chao and Ahern, where you would find significantly more examples of those landscape metrics. You are familiar with landscape metrics from all the previous chapters by Foreman and Gordon. It's quite, you are very comfortable with it by now. You have used many examples of landscape metrics, including some examples in the previous lab. We were looking at the edge or connectivity or distance between different patches, the shape of boundaries of patches, stepping stones, matrix porosity. So those are just some examples. So think about what kind of landscape indices, what kind of landscape metrics might be useful for your project, what will be relevant in your study area. And so here, again, in the readings, you would find more ideas about what is really the purpose of landscape metrics. Remember that the landscape metrics can be assessed and calculated using computer programs such as Fragstat or as patch analyst within ArcGIS. So you can actually evaluate, you can run those programs on your maps or your landscape maps and calculate, for example, matrix porosity or richness of matrix or contrast of edges and so on. So in the lab 4, you would need to explore how the landscape metrics can be used in your planning project. So some examples of landscape metrics are available in table 4. on page 78 in Leitao and Aachen. This article is available in your optional readings on the Blackboard. Please use it in Lab 4. It might be also useful for your project proposals, especially the second round of your project proposals. Now, this is also a good opportunity to explore how different steps of landscape planning should address both horizontal and vertical perspectives, both chorological and topological perspectives, as it relates to your project objectives. So this is something more for your discussion and self-reflection. What are the most fundamental flaws of the traditional land use planning in the United States? Where you see the major gaps, how it can be improved with integration of landscape ecology in the traditional urban planning and land use planning practices. Also, think about what are the key attributes of landscape process. So the required chapter by Ahern explores quite well what are the key attributes and what are the key steps of the landscape planning process. So we are going to look at those steps more in depth as we are preparing to complete the Lab 4. As you are going through the chapter 10, make sure to be able to answer those questions. So who should determine the goals for the landscape plan? Is it the planner? Is it the community? Is it local government? Why the relationships between the landscape pattern and process are so important? Why the planning process should be replicable? Are we planning only once for one place, for one goal? Is there any connection between our different planning projects and how they're related and who should be involved? Also, why the landscape planning is always strategic and what kind of strategies should we use as we are developing our planning project? And finally, why landscape planning is an iterative process. There are multiple layers, multiple temporal iterations. So you might think that we're approaching the goal, but then this is actually time to reevaluate if implementation is actually working and we sort of start the process again at the next level. This chapter is also providing lots of useful information about planning strategies. So there are 4 groups of strategies, and I'm going to elaborate a little bit on each of them. These 4 groups are protective, defensive, offensive, and opportunistic, and they're very well explained starting with page 187. Make sure that you understand and know these planning strategies. They will be on our quiz for this Thursday and Friday. So if you have any questions, please email me or Zoom with me. And so think also about why do we need, how we apply those strategies, and how we can develop future landscape scenarios when we would see the outcomes of applications of those strategies. And think also about the difference between the scenarios where we are focusing on a particular state of our landscape versus scenarios where we are focusing on the processes. And so we need to anticipate what kind of processes we will see in the future landscape. So a little bit about each of these 4 types of planning strategies. Let's start with protective strategies. Those essentially the simplest and the least expensive strategies. They work quite well when we actually still have something to protect in the existing natural landscape. So if we want to protect certain biodiversity resources or certain types of landforms, or maybe some historical site, we can limit access, we can create whatever protective mechanisms, either as policies or as physical barriers. We can restrict access to a certain area that will help to protect it. Protective strategies are only useful when there's still enough of natural elements within the landscape to protect. So we want to protect the creek from erosion, or we want to protect particular species, we can fence it out, or we can restrict the human access. Defensive strategies are usually working much better when there is already significant disturbance within the landscape and we really need to stop it. So those are quite ad hoc, usually very reactive measures. This is not the best way always to develop the landscape. This is essentially the reaction to damage happening within the system or damage that has already occurred. So in the tutorial today, I was talking about the way how JVSU is managing ravines versus the way how Ottawa County is managing ravines in the Grand Ravine Parks. And so we see kind of those defensive strategies when we're trying to put some gravel on the slopes, we're trying to enforce the slopes, we're trying to reduce erosion, we are trying to plant some trees, but really we are not working systematically to restore our ravines, and so there's quite limited success with practicing those defensive strategies. Defensive strategies are usually much more expensive than protective strategies, but they're less expensive than offensive strategies, and that's why sometimes they are preferred by planners, even though they don't always offer the best results. The next level of more intrusive into the landscape, but also more integrated strategies are offensive strategies. Offensive strategies are preemptive, differently from defensive strategies. They not only address the disturbance, but actually preempt the disturbance. You have to plan offensive strategies years ahead. We're actually working on prevention of erosion, or working on prevention of pollution, or we're working on prevention of certain disturbances in the landscapes by redesigning the entire landscape system. And so usually those are very complex, very expensive projects. Offensive strategies are not cheap, but they give us much better results than defensive strategies because they really work with the entire landscape as a system, taking into account both human needs and the needs of the entire ecosystem. And finally, opportunistic planning strategies. Opportunistic planning strategies essentially fit into already existing landscape elements, and that can be the use of the gravel pit as a lake, or it can be the use of the railroad that would be reconfigured as a biking trail. There are many examples, and the opportunistic strategies don't necessarily work everywhere. They can be very inexpensive or they can be very expensive. It really depends on what kind of landscape, already existing landscape elements we want to adapt for the new use. So in the lab 4, again, I will be asking you to look at some potential planning strategies that you could use in your study area. Please remember that you don't have to use them on different strategies work best for different areas. Don't feel disappointed if you don't feel the good place for some of those strategies in your project or in your study area. And this chapter concludes with an example on pages 219, 221 on how to develop your own planning process step by step, using concepts and using the principles of landscape ecology in land use planning and urban planning. So please examine on your own and discuss or reflect on the open space plan for Orange, Massachusetts. And that would be essentially kind of the blueprint for us to adopt in the Lab 4. You will be using the similar process, using the flow chart that you would find in these examples for Orange, Massachusetts. You would be using the same steps for restructuring your project proposal in the Lab 4. So once again, I think that would be very useful for your project proposals. But the project proposals are due after tomorrow, they're due Friday. So don't feel that you have to incorporate everything from this lecture or from the lab into the current version of your project proposal. That will be, as you start working on the Lab 4, that will be a very good time to reflect on what you are going to submit this week, and then also look at my feedback, look at the comments from the class, and then hopefully you would use some of this information in your revisions that will be due October 30. So this is all for today, and I will see you online, and I will see you next week.